Okay, so we're going to look at some examples of solving rational equations, and the process we're going to use is to multiply both sides by the LCD, the least common denominator, to clear the fraction. So that's the directions you will be given. So make sure you're solving those rational equations that way. And so as you go through the process, just go through these steps. So you're going to find the least common denominator, and then you're going to find any restrictions. Then you can multiply both sides by the least common denominator. Then you're going to remove any grouping symbols by using distributive property or foiling. Then you can combine like terms, reduce if possible. And then you're going to solve the resulting equations. And the resulting equation may be linear or it may be quadratic. And then you're going to check for extraneous solutions. And for the most part, you're going to check these extraneous solutions by just looking at your restrictions. Okay, so let's look at number one. So number one, we have this rational equation, and notice that this rational equation is made up of three rational expressions. In this case, you have variables in the denominators. And so the first thing you want to do when solving a rational equation is to find the least common denominator. And to find the least common denominator, remember you got to factor the denominators. So if I look at that first denominator, I can factor that as x minus 4 times x minus 3. And then this denominator, I cannot factor. The GCF is 1, and the same thing here. So the least common denominator, remember, must include every distinct factor that you see. I see an x minus 4, that has to be in the LCD. I see an x minus 3, it has to be part of the LCD. X minus 3, I already have it. X minus 4, I already have it. Don't include it again because it's no longer a least common denominator. It becomes a common denominator, and then it would make the process of solving this equation more complex. So that's your least common denominator. Once you find your least common denominator, the next step is to determine what the restrictions are. And so to determine the restrictions, you're looking for values of x that will make this denominator 0, this denominator 0, and this denominator 0, because you can never divide by 0. So you got to determine, first of all, what's going to make that 0. So for example, this is the easy one here. So if you notice that the value, when x is 3, I get 3 minus 3 is 0. So this becomes 2 divided by 0. So you found one of the restrictions. One of the restrictions that x cannot equal 3, right? Because 3 minus 3 is 0. Same thing here, and that's the easy one to deal with. 4 minus 4 is 0. So another restriction that x cannot equal 4. So you found the restriction here, you found the restriction here, and then you go and you find the restriction here. But notice that these factors are the same as these. So what makes this factor 0? We already found it, 4. What makes this factor 0? We already found it, 3. Okay, so those are restrictions. Once you find the least common denominator and once you find the restrictions, the next step is to multiply both sides by the least common denominator. And remember, the whole point of multiplying by the least common denominator is to clear those fractions. So you're going to end up with factors of 1, and you're going to see that as we go through the process. All right, so the left-hand side is just one rational expression, and the right-hand side is 2. So when the process, we're going to put this in parentheses. So I have the LCD, which is x minus 4 times x minus 3 times the right-hand side. I'm sorry, the left-hand side, 5 divided by, and leave it in factored form. Don't leave it as is trinomial. Leave it in factored form, and the reason is because these factors are the same as these, and so you can easily see that they will divide out. So x minus 4, x minus 3 equal. Now I'm going to say the LCD, which is x minus 4 times x minus 3 times, I'm putting this in brackets or parentheses, whatever you want to use, times this side. I'm putting in brackets because this is more than one rational expression. So 2 divided by x minus 3 plus 5 divided by x minus 4. Okay, now since I introduced some grouping symbols here, I'm going to go ahead and distribute, and I'm going to go ahead and rewrite this, and then we're going to talk about what to do next. So x minus 4, the LCD times the first rational expression. All right, and then I get the LCD times this rational expression. So x minus 4, x minus 3 times 2 divided by x minus 3 plus the LCD times this. So x minus 4, x minus 3, and I'm running out of room. Okay. All right, now we're going to reduce. We're going to reduce. So notice that the x minus 4 is divide out, the x minus 3 is divide out, right? Now remember what we said. So the whole point the purpose of multiplying both sides by the least common denominator is to get these denominators to be factors of 1s. So you're basically clearing the fractions. Same thing here, the x minus 3's divide out, the x minus 4's divide out. Okay, so you have 1 times 5, which is 5, equal. Now you got to be careful here, that's x minus 4 times 1 times 2. So let's put the 2 in front. So that's 2 times x minus 4. In parentheses, the x minus 4. Plus, and then same thing here, 1 times x minus 3 times 5 is 5 times x minus 3. All right, so notice I went from a rational equation to a linear equation. So to solve this linear equation, I'm going to go ahead and distribute first. So I get 5 equals 2x minus 8 plus 5x minus 15. Combining like terms, I get 5 equals 2x plus 5x is 7x. A negative 8 and a negative 15 is a negative 23. All right, now I'm going to go ahead and add 23 to both sides. And so I get 28 equals 7x. Divide both sides by 7. I get my proposed solution to be 4. So that's a proposed solution. All right, so this is a solution to the linear. You can see that it is, because look, the left hand side is 5. 4 minus, when if x is 4, I get 4 minus 4 is 0, right? 0 times 2 is 0. 4 minus 3 is 1. 1 times 5 is 5. So 0 plus 5 is 5, and 5 equals 5. So that's a proposed solution, though. But the question is, remember, you got to check for extraneous solutions. And so you got to ask yourself, well, this proposed solution is a solution to the linear, but is it going to be a solution to the rational equation? Well, just check your restrictions. As long as the algebra is correct here, then all you have to do is just check the restrictions. And so notice x equals 4 is one of my restrictions, so I cannot use it. So this is an extraneous solution or extraneous root. So it's a false solution. So then you got to say this now. You got to say the answer. You're going to say answer. You're going to say it's going to be no solution. So you have to say no solution. So that was your only proposed solution. So then you're going to say no solution. So this equation has no solution. All right, so that's number 1. Okay, now let's look at number 2. Number 2, we have this problem for number 2. All right, let me go ahead and find it. So here's number 2. All right, number 2. All right, we have 1 minus 3 divided by b equals 10 divided by b squared. All right, now this is an easy kind because the denominators are monomial factors. And so the least common denominator is going to be just b squared. All right. Now also the restriction is easy as well, because you can look at this and ask yourself, what value of b will make this denominator 0? Well, when b is 0, because 3 divided by 0 is undefined, right? Same thing here. 0 times 0 squared is 0. 10 divided by 0 is undefined. So the only restriction is that b cannot be 0. Now, once you find your least common denominator, remember the next step is to multiply both sides by the least common denominator. So I have 2 rational expressions on this side. Yes, 1 is a rational expression. A constant, an integer is a rational expression, 1 divided by 1. But I'm going to leave it as 1, so I get 1 minus 3 over b, and I'm going to multiply that by the least common denominator, equal the least common denominator times this fraction. Okay, then I'm going to distribute. So I get b squared times 1 is b squared minus b squared times 3 divided by b, this times this, equal. I'm going to go ahead and rewrite this over, b squared times 10 divided by b squared. Then I'm going to go ahead and reduce what I can. So I get b squared. This factor b reduces with one of these. So you get b times 3, which is 3b, equal. Both factors of b divides into both factors of b here. And so 1 times 10 is 10. So notice I went from a rational equation this time to a quadratic equation. All right, that's a quadratic equation. So let's go ahead and solve this quadratic equation, put it in standard form. And so you get b squared minus 3b minus 10 equals 0. And then we're going to factor this. So I get b, that's going to be minus 5 plus 2. And then I'm going to use a zero factor property. So I'm going to set each of these equal to 0. So remember, when you have two or more factors whose product is 0, one of them has to be 0. And so I get b to be 5 and b to be negative 2. Remember, these are your proposed solutions, right? So those are actually solutions to this quadratic. And you can check it. Look, let's try 5. 5 times 5 is 25. 3 times 5 is 15. 25 minus 15 is 10. Negative 2. Negative 2 times negative 2 is 4. A negative 3 times a negative 2 is a negative 6, is a positive 6 rather. 4 plus 6 is 10. But are these proposed solutions a solution to the original, to the rational equation? Yes, because the only restriction is 0, and these are not zeros. So the solutions are, so you can say the solutions. So these are not extraneous solutions. So those are those are not restrictions. So the solutions are b equal 5 and b equals negative 2. Okay? All right. Now remember, these are called proposed solutions. So you got to check and see if they're actually solutions to the um, original rational equation. All right, that's number 2. All right, and then finally let's look at number 3. So let's suppose in number 3 I had this one. All right, number 3, we have 2m divided by m minus 1 plus m minus 5 divided by m squared minus 1 equal 1. All right, so I have this rational equation, and first thing I got to do is I need to factor this denominator, and that's the difference of two squares. So I get m minus 1, m plus 1. And so my least common denominator, remember, must include every distinct factor that you see in all of these denominators, and this is 1 divided by 1. Remember that, 1 divided by 1. So my least common denominator is going to be m minus 1. I already have m minus 1. The next one's m plus 1. I must use it. And that's a 1, and 1's a factor of every expression. So that's your least common denominator. Now you got to find your restrictions. So you got to ask yourself, what makes this factor, this denominator, 0? What value of m makes it 0? Well, 1, right? 1 minus 1 is 0. So m cannot equal 1. Now, again, what makes this factor 0? We already found it, 1. What makes this factor 0? So you're asking yourself, where is m plus 1 equal to 0? Well, m plus 1 is equal to 0 when m equals negative 1. So my other restriction is that m cannot equal negative 1. And this denominator here will never be 0. It's always going to be a 1. All right, so there you only have two restrictions. Okay, now we're going to multiply both sides by the least common denominator. All right, so I'm going to go ahead and rewrite the left-hand side, and we're going to multiply that by the least common denominator, m minus 1, m plus 1, times the left-hand side, 2m divided by m minus 1 plus m minus 5 divided by, and write the factored form, m minus 1, m plus 1, equal. And then I'm just going to say 1 times m minus 1, m plus 1. Okay. Now, I'm going to go ahead and distribute, get rid of the grouping symbol. So I get m minus 1 times m plus 1 times this fraction, and then plus the LCD times this fraction. So m minus 1, m plus 1 times m minus 5 divided by m minus 1 times m plus 1 equal, and then 1 times these two binomials is just the product of these two binomials. Okay, so that's where I'm at. Now I'm going to reduce. So the m minus 1's divide out. The m minus 1's here divide out. The factors of m plus 1's divide out. Notice I'm getting factors of 1's in my denominator. That's what I need, right? So the whole purpose of multiplying by the LCD is to get these denominators to be 1, so to clear the fractions. All right, and that's all I can reduce. So I get 1 times m plus 1 times 2m. So we're going to put this monomial factor in front. So 2m times m plus 1 plus 1 times m minus 5 is m minus 5 equal. And I'm going to go ahead and rewrite this. M minus 1, m plus 1. Okay, now let's go ahead and distribute here, and we're going to FOIL here because that's a product of two binomials. So 2m times m is 2m squared. 2m times 1 is 2m, and then plus m minus 5 equal. Over here, I get m times m is m squared. The outer is a positive n. The inner, I'm sorry, a positive m. The inner is a negative m, so that cancels out, and then you're left with negative 1 times positive 1 is a negative 1. Combining like terms over here, I get 2m squared plus 3m minus 5 equals m squared minus 1. So I want you to notice that I went from a rational equation to a quadratic again. So that's a quadratic equation. So I'm going to solve this quadratic equation. I'm going to write it in standard form. So I'm going to subtract m squared from both sides. So 2m squared minus m squared is m squared plus 3m minus 5 equal a negative 1. Then we'll go ahead and add 1 to both sides. Notice I'm aligning my like terms. So I get m squared plus 3m minus 4 equal 0. And then I'm going to go ahead and factor. And so when I factor, I get m plus 4, m minus 1 equals 0. And so I'm going to set each factor equal to 0 using the zero factor property. So m plus 4 equals 0, m minus 1 equals 0. So m equals negative 4, m equals 1. Now remember, these are your proposed solutions, right? So these are solutions to this quadratic equation. But you got to ask yourself, are both of these or any of these solutions to the rational equation? So that's where your restrictions come in. So I can't use 1 or negative 1, and notice this is 1. So this right here is this proposed solution, m equal 1, that's a 1 here, sorry. So that solution is a extraneous, so it's a false, so that's an extraneous solution. So m equal negative 4 is the only solution. So the only solution is m equal negative 4. Okay? All right, so that is solving rational equations by multiplying both sides by the least common denominator.